For over a century, humanity believed the universe had drawn a hard line, an unbreakable speed limit etched into the very fabric of space-time. Nothing with mass could travel faster than light. It was Einstein's gospel, the ultimate wall, and so generation after generation, we dreamed within that cage. Our movies dared to imagine warp drives, hyperspace, wormholes. But science always stepped in to whisper, nice fantasy, but impossible. Until now. Because behind tightly guarded lab doors and through mysterious research leaks, a quiet revolution has begun to crack the cosmic code. Scientists have discovered not one but several mathematically sound ways to travel faster than light. And not just by a little. We're talking 10 times faster. Suddenly, ideas once dismissed as sci-fi hallucinations are being printed in peer-reviewed journals. The future isn't knocking, it's warping space on our doorstep. And if this technology becomes real, everything changes. Time, distance, even reality itself. So hold on. Because what you're about to hear might be the first chapter in a story that ends with humans leaving the galaxy forever. Since 1905, the speed of light, roughly 299,192 kilometers per second, has haunted physicists like an invisible ceiling. The closer an object with mass gets to this speed, the more energy it demands. To actually reach it, that would require infinite energy, physically impossible. Or so we thought. For decades, this law was treated as sacred. It defined what was possible and what was not. But there was something the textbooks left out. Einstein's theory describes motion through space, but it doesn't account for moving, space itself. What if, instead of pushing a ship through space-time, we could bend space-time around the ship, like standing still while the road rushes beneath your feet? That's the loophole, the exploit, the backdoor in the code of the universe. And now it's no longer just a cool idea from Star Trek. Mathematicians and physicists are converging on this point, racing to master the geometry of warp fields. Bubble-like distortions in spacetime that could make superluminal travel not just possible, but practical. Enter the Alcubierre drive. First proposed in 1994 by Mexican physicist Miguel Alcubierre, this concept was a game-changer. He theorized a warp bubble that compresses space in front of a ship and expands it behind. Inside that bubble, the ship doesn't move at all. It simply rides the distortion, like a surfer on a cosmic wave. From the outside, it looks like it's traveling faster than light. But according to relativity, it's not breaking any rules. The ship isn't moving through space. It's making space move. For years, this idea stayed in the realm of theory because it required absurd amounts of exotic matter with negative energy density, something we weren't even sure existed. But then came Harold G. White. While experimenting with the Casimir effect at NASA, White's team stumbled across something breathtaking, naturally forming micro-warp bubbles, real distortions in space-time, observed at the nanoscale. Suddenly, warp fields weren't just hypothetical. They were measurable. And the energy requirements dropped from infinite to something closer to a few hundred kilograms of exotic material. Still a long shot, but no longer a fantasy. As whispers spread in scientific circles, something fascinating happened. Researchers in Germany, the US and Japan quietly began running warp physics experiments of their own. In 2024, a team at the University of Potsdam used gravitational wave simulations to test how warp fields might appear if they were real. The results were stunning. Not only did they replicate theoretical warp bubble signatures, they also discovered that similar patterns may already exist in archived data from observatories like LIGO. In other words, warp fields, artificial or natural, might already be rippling through the universe. And here's where it gets even stranger. Those simulations suggested we could reverse engineer warp structures, meaning if we can recognize the gravitational fingerprint of an alien warp drive, we might be able to copy it, like finding tire tracks in the dirt and using them to build a car. For decades, warp drives were treated like unicorns, poetic, pretty, and purely imaginary. But today, 3 independent models exist with real math behind them. Alcubierre's original design, the modified Notario drive, and White's energy-efficient bubble geometry. None of them require breaking the laws of physics. All of them. Sidestep Einstein's limit, not by smashing through it, but by going around it. And here's the sobering truth. This research isn't just being fueled by curiosity or Hollywood dreams. It's being fueled by necessity. Earth is fragile. We have no backup planet. If we want to survive, not just as a civilization, but as a species, faster-than-light travel isn't optional. It's inevitable. But here's where things get mind-bending. If traveling faster than light bends space, what happens to time? In Einstein's world, moving near light speed causes time dilation. Clocks slow down, distances contract, your mass increases. Push beyond that speed, and causality itself begins to fracture. Events could happen before their causes. Imagine turning on a flashlight, and the beam hitting the wall before your hand even moves. That's the paradox. But warp theory has a clever solution. Inside a warp bubble, you're not accelerating at all. You're standing still in a calm pocket of space-time while the universe moves around you. That means no time dilation, no relativistic mass increases, no paradoxes. It's like folding a piece of paper so two distant points touch. You don't cross the distance, you collapse it. But if warp travel becomes real, we won't just need to redefine speed. We'll need to redefine sequence. Because once you're moving faster than light, the question isn't where are you going anymore, it's when. And that raises an unsettling possibility. Harold White's team didn't just stumble on warp bubbles, they may have stumbled on a blueprint. Their experiments revealed bubbles with properties eerily similar to warp field equations. And these weren't created, they were discovered. So, what if the universe naturally produces warp bubbles? What if they're baked into space-time itself, waiting to be unlocked? And what if some of those natural bubbles aren't natural at all? What if they're footprints, remnants of alien engines racing through the cosmos long before us? If we can trace those imprints, we don't need to invent warp travel from scratch. We just need to follow the trails they left behind, like ancient humans copying constellations onto cave walls. We might be copying the highways of gods. It's no coincidence that while this research gains momentum, the silence from NASA, SpaceX, and the Department of Defense is deafening. Rumors of classified propulsion projects have swirled for years, and Harold White's lab, while technically under NASA, operates with unusual independence. Meanwhile, Elon Musk has dropped more than a few hints about non-traditional propulsion, being necessary for Mars and beyond. If a prototype exists or is already being tested, it won't be announced. It'll be hidden. Because once warp becomes real, the race won't just be scientific. It'll be geopolitical. And whoever controls space-time doesn't just win the future. They define it. The implications stretch far beyond travel. According to the Kardashev scale, humanity isn't even a Type 1 civilization yet. We haven't mastered the energy of our own planet. A Type 2 civilization harnesses the full power of its star. But a species that controls space-time itself, that's beyond Type 2. That's rewriting the universe. Warp bubbles, Casimir vacuums, gravitational geometries. They're not just propulsion systems, they're doorways into a new kind of physics, a future where distance is meaningless, where here and there dissolve into choices. In short, we wouldn't just be building ships, we'd be building a new version of humanity, one unbound by the rules of the past or even the limits of the cosmos as we thought we knew it. For centuries we looked at the stars and imagined roads, planets, and frontiers. But the truth is, the universe was never built like a map. It was built like a fabric, and maybe we were never meant to cross it. Maybe we were meant to fold it, to reshape it, to see space not as an obstacle, but as a tool. Warp technology is no longer just science fiction. It's becoming engineering. And in this century, perhaps even in this decade, we may witness the first artificial ripple in space-time made by human hands. From that moment on, the stars are no longer distant. They're next door. But this isn't just about travel. It's about identity. Because the moment we bend the laws of the cosmos to our will, we stop being a civilization of Earth. we become something else entirely, a civilization of space-time. So now the question isn't if we'll do it. It's who will do it first. And what will they find waiting on the other side? If this video made your imagination ignite, don't let the conversation end here. Do you think warp travel will happen in our lifetime? Or are we opening doors we were never meant to touch? Drop a comment below. Hit that like button if you believe the universe still has secrets to reveal, and subscribe. Because next time, we're diving into the one discovery NASA refuses to discuss publicly: